Welcome to the Digital Amateur Television Experimenters Night. This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate in the night by coming up to the Queen's Domain clubrooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
On the right dial.
You get all excited.
Okay, that's right. Let's go there and now go to there. Oh, come on. What's going on here? That's better. Alright, and I'll show you what we're looking at. This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania with our DATV Experimenters Night. And I welcome Rex back into the state. VK7MO, good evening, Rex.
Thank you, Justin.
And we also have a full studio audience tonight in Richard and Hayden and Larry.
Do a pan.
Do it. Well, I can do a.
Oh, can you?
I can do a little bit of a pan here. Just bear with me because if we go to this particular camera, which so you're actually seeing there's
Wow.
there's our studio audience, and I think I can come down to Larry here.
You might have to stand up.
There we go, Larry. There's Larry.
Okay.
So we'll come back to here. So we have a full studio audience here who's going to be quizzing Rex on the way through his presentation. So I will hand to Rex. Go for it, Rex.
Well, thank you. But which buttons can I press to change the slides? Thank you.
There you go.
Which one? The right or the left? Or
the right one, I think. So.
Okay. Some of you will be aware that over Christmas and up into January I went over to the mainland with the objective of trying to work 10 gigs terrestrial between VK and ZL, and
No, keep going. Keep going. Keep going.
Why is it not wanting to change?
Oh, okay.
No. Which one is that?
Yeah.
Okay. The yes, the path doesn't show up here, but basically the plan was generally tropo ducts opened between Australia and ZL in the period mid-December to the end of January, and sometimes a bit wider, but that's when they mostly happen. So what I did is I went over and stayed at my son's place in Melbourne with the view that if I saw a duct on Hepburn, I could wander up the east coast of Australia to an appropriate spot and try and work ZL3RC. Now, Roger actually lives on the wrong side of all the mountains in New Zealand. He lives in Christchurch. So he had to go portable also, drive over the mountains to near, just a little bit north of Greymouth on the west coast. The problem is ducts are never high enough to get over the Alps
In New Zealand.
in New Zealand. So anyone who works Roger normally must be doing it on sporadic. He as
Or EME. Or EME.
or EME, yes.
Good point.
So that was the basic plan. I did have some family obligations which suggested I should stay in Melbourne over Christmas.
Right.
But I did warn them if a duct really turned up just at Christmas, then Christmas was going to take second place. So, but I was hoping the duct didn't turn up then.
Right.
So, next slide.
Just bear with me, yes.
Now, this is a typical situation. You can see that high with 1021 millibars. Actually, in this today, people call them hectopascals. It just shows you how long ago I worked for the Bureau of Meteorology. And typically, the best paths are ones that go through the centre of the highs. So people generally work from New South Wales to the North Island of New Zealand, and most of the ducting contacts are done on a path like that. In the 10 years I've been in Tasmania, I've only had 2 really strong ducts from my place to the North Island of New Zealand when the high was a bit lower, but there was another one, wasn't there, Hayden?
Yeah.
Where was that?
The same, or the day before you had the contact.
That's right.
Yes.
Now, part of that is because you would have been working people right up at the top of the North Island,
Yeah, it was as far north as you could just about go.
which
Yep.
sort of gets you through
And there was nothing further south. Nothing
south,
at all.
because that's right.
Yep.
And so, if you're going to work someone on the South Island, you've actually got to be at least somewhere up in New South Wales to
Yep.
go through a strong part of the high and get a good duct. So the plan was to go somewhere. So next slide. Oh, this doesn't show up real well. But if this was on the 23rd of December, and there was a forecast for the 27th of December, and it does show an area of ducting looking a bit interesting across from central New South Wales across to the yeah, that's a bit better.
The purple bit.
Yeah, but not quite getting to the South Island, but starting to get a bit interesting. And so I said to Roger, look, I don't think it's quite ready for me to depart now, and there was another reason for that. This was still the 23rd of December.
Right. Okay.
So then a couple of days later, Christmas Day, we looked at the Hepburn charts, and this doesn't show up nicely, but this is about the most intense duct I have ever seen.
Oh, truly.
Now that black line,
And it's across to the South Island.
and that's right, that's right. So this looked really promising. But you probably can't see on there, but there's a couple of unstable areas, both above and below it, and so the duct really only gets through to the coast
In a pretty narrow little area.
a little area which looked like Narooma was about the place to go.
Okay.
Next slide. Now, fortunately, I've been to Narooma before, working 10 gigs aircraft scatter, and I had a nice location here. And you can actually beam right out to the ocean between those trees, and you're up, well, maybe 100 metres, and so it that looked promising.
Nice takeoff.
The only little concern I had is to access this site. It's a real bush track through trees, and there were fires north of me at that stage.
That's the
next slide. So the fires were up from Bateman's Bay up, and I thought, well, no, 55 kilometres away, I'm not going to worry about that. So next slide.
Did you get any smoke at that stage down Narooma?
I didn't go to Narooma because the day I was about to leave, the Hepburn chart showed that well, it was there, but it had moved further up. That intense bit, and it wasn't it was a bit of a gap getting across to New Zealand. So I sort of thought, if this is moving up and this is an unstable area, I'm better off to go north of Sydney. Now the only problem is there were also fires north of Sydney, and I was thinking, well, if I go on the inland route and then cross between the fires, that might work. But what I decided to do is drop in on Glen in Canberra, both to pick up my 9700 with the Mark II board.
Yes.
And also, Glenn gave me a whole lot of advice.
That's the next slide.
Next slide. So he picked out a number. Glenn does a lot of VHF radio in his professional work in different places. So he picked out a couple of sites near Bulahdelah that he thought were worth me trying. And he contacted Ross 2DVZ, who I know pretty well. Ross said he really wasn't the expert on the sites, even though he lives in the area, and suggested I talk to Henry VK7TW, who's the president of the Port Macquarie Radio Club.
I see. Yep.
Henry showed me around some sites, very friendly, helpful guy, and told me about their repeater site at Yarrahapinni.
It's got to be an Aboriginal name.
I think so. So next slide. I went up to Yarrahapinni. It doesn't show too well in that picture, but there's a brilliant takeoff there.
Well and truly.
Out to the ocean, in the direction I wanted. This was about 35 kilometres north of Kempsey. And I went up and explored this site. The roads were pretty rough and hard to get to, but after I came down, I went in, got into the internet and got the Newcastle Radiosonde data to see the height of the duct. And here was the Newcastle Radiosonde data with quite a strong duct, well over minus 400 N units per kilometre. You only need 157 to compensate for the curvature of the Earth.
That's what the dotted line is?
That's right, that dotted line. So this looked really promising.
Definitely.
The only problem was the duct was at 372 metres and the Yarrahapinni site was at 410. So we were going to be above the duct. And they bend up. So it doesn't work. Now admittedly, I also looked at the Brisbane duct and it was higher, and if you did if you assumed there was a gradual change between Newcastle and Brisbane, then it was probably going to work at Yarrahapinni, but it was on the margin, and I thought I better look for a site lower down. So went searching for more sites. Henry had told me a couple of sites if I needed to go lower down at Stewart's Point, and I was looking for those, and I actually couldn't find the sites, but I get a phone call from Grant to MAX, who's been talking to 2DVZ, the grapevine.
The grapevines were well and truly going.
I even had a message from Colin VK2KCM, and he said to me, "What's Rex's number? I've got a good site for him." And I'm going, "I don't know what you're talking about." So I sent through the number. He must have called you and said you're already talking to Grant.
That's right, exactly.
So it was really going around.
My mobile phone's going crazy with people wanting me to go to different sites.
This is the whole community facilitating your export.
That's right. It was wonderful. Anyway, Grant told me that to meet him at a little town which I can't remember, and so I put the GPS on, which took me by some circuitous route because they rebuilt the highway up there and my GPS didn't know where I was. And I met Grant, and he took me to a place called Hat Point, where he has often worked across to ZL.
Okay. Right.
And Crescent Head. Now, Hat Point's a beautiful spot. It's only probably 20 metres above sea level, and I'd like to be a bit higher than that, so if the duct's further out, you can see out. And he said, but you'd love Crescent Head. So we went to Crescent Head, and it was ideal. It's 72 metres, so you can see a long way out over the sea.
Yep.
And Grant also invited me to stay at his home, which I did for the 3 days. So I had accommodation, didn't have to sleep in the car, and
Always good.
got fed. Luxury. So, next slide. Now, if you look at where the fires are, this is a couple of days after we did it, you can see Crescent Head is on one of the few places where there's no fires.
But it's surrounded by fire.
But it's surrounded by fire. And the rumour would have been an absolute disaster. And in fact, the expanded scale there, you can see how close the fires got to Maruma. And the spot I had picked out was about several kilometres inland.
But you were 55 kilometres away from the fire when you first looked at it.
That's right.
Yeah.
It's a bit scary, isn't it?
So, very fortunately, I made a decision because of the unstable bits on Hepburn to go further north.
Yep.
Now, I did go through quite a lot of burnt areas up there, not actually smouldering, but
but very recently burnt areas.
Very recently burnt areas. So, next slide. Now, this is Crescent Head looking out over the water.
Wow.
And you're up 72 metres. The other good thing about this is that there's a really good surf beach, but it's down the hill, and so everyone parks generally down the hill.
Cool.
People do come up to the top of this hill just for a quick view, but as long as you grab the parking, there's only 3 parking spots if you get there early. Yeah, you're right. Now, next slide. This one's the same shot, but just to show the differential GPS antennas.
3 cheers for David.
Yes, David 3HZ. And when we ultimately did some peaking up, the thing was spot on.
Fantastic.
Azimuth. So,
Okay.
and that's only probably a 6 metre baseline.
Yeah,
So-
okay.
So, next slide. Now, this is Roger's setup at the other end. He didn't have differential GPS, but next slide he gives you a photo of what the view was
Whoa.
from the dish.
Yeah, okay.
And you can see there's some rocks out in the sea.
Yeah, okay.
Now, looking at rocks on Google Earth when the tide might be different.
A bit like looking at clouds.
Yeah, yes. But nevertheless, it got him pretty close. I think he was about 1 degree out.
Hey,
So
that's not bad.
that's not too bad.
Cool.
Next slide. Now, as soon as we actually set up, I swapped over. Well, I initially sent a single tone on 432, and signals were pretty good, and we had a QSO. we swapped over to 10 gigs, and these are essentially rock crushing signals on QRA. When it gets down to sort of minus 12, the signal actually starts to compress on QRA when you get below about minus 14. So they're probably 10 dB stronger than that's reported. So that looked pretty good. We did swap over. Oh well, I'll just show you what happened the next day. Now the next day, you can't see this too well, but there's actually at the bottom you can see a signal going whoosh and then whoosh back,
yes.
and it's doing 2 kc in just a 1 minute period of drift.
Wow.
Now,
Rogue 9700.
well, we didn't know what the problem was, and Roger asked me, he says, "You're drifting." And I said, "Oh, well, I'll check against my second little GPS logged signal source." And the communication was really poor. We're trying to do it using what's it?
Logger?
No,
Messenger.
Facebook Messenger.
Oh yeah.
But he didn't have good internet connection.
I found that's a common thing in ZL.
Yeah, is it?
Yeah. At remote places, internet connection is not very good.
No.
Right.
Well, at least where they go to set up.
So it would sort of,
Okay.
you know, we sort of half get messages through, and I'm thinking, I'm pretty sure I'm stable. And Roger obviously thought it wasn't at his end because he had his GPS there and everything.
It's quite an interesting because it's quite a linear, and then it comes back again.
Yeah. Now, you'll see after a while, it's still not stable, but it's not drifting nearly as much. And what he did there is he removed his GPS from locking his 10 gig system, and it just relied on the crystal in the DB6NT, which is got a little heater on.
That's still not too bad, just for...
Well, it was drifting 50 hertz or so in a minute, but not good enough for digital.
Okay, for voice.
Well, you might have thought so, but in practice, with the fact, because our liaison was lousy, we finished up stuffing up, and he couldn't find me again.
Oh, okay, yeah, okay. Right.
So about this time, he walked up a hill and got some better internet, and he said, "Look, yes, it does look like it's my GPS is not locking." He's using one of these G3HUF,
G3RUH, the
RUH ones.
Yeah, Jim Miller ones.
Now the trouble with those is they've got no holdover capability. If they've got to have
If it goes,
GPS signal all the time.
Oh, okay.
Yes.
And I think it turned out that when I talked to Kevin for UH, he had the same problem with the same GPS.
Okay.
And he found that it was due to actually a poor connection on the antenna.
Socket. Okay.
Socket.
Dropping in and out with
Yeah.
the GPS all the time.
Yeah, and then the thing goes searching and and
It takes a while for it to...
Yeah. So the lesson for me is always use a holdover
The GPS.
GPS. We never found out exactly what went wrong because Roger brought it back to his house and it was working perfectly.
Of course.
So the second day was obviously signals were there because if you look at when it was drifting fast, it doesn't spend enough time to show up very strong.
Yeah.
But when it was drifting slowly, it was clearly a solid signal.
Oh, true.
So it would have worked, but we.
But the mode
Didn't have enough
deal with that
stability to
drift.
do that.
Yeah.
That's right.
Yep.
Okay, next slide. So the first day, we had a really touch and go SSB contact 3-in-1 both ways.
Yep.
Second day, Murphy hit and nothing happened. The third day, signals were getting stronger throughout the day, and we started off 5 and 3 both ways, then 5 and 5 both ways, and it peaked up about 5 and 7. Now, I don't know, you've got a way of playing this, haven't you? Do you want to play that now or later?
Yeah, let's try. let's just try.
While Justin's doing that, that was one thing we noticed on that duct. Signals were up and down, but they were fairly consistently up and down. So like
consistently up and down.
ZL would come in for maybe, I don't know.
No, hang on. I've got to move.
It's
Keep
the
going.
second one.
Is it?
That we want?
2457.
The second one. Oh, that might be it. That sounds pretty solid, doesn't it?
Let's. Now that's Roger videoing the screen, which is fairly difficult to see in the video to start with. So on here we haven't got a hope in hell.
I think this.
But that's the tone.
I think that might be the first one without.
Okay.
Yeah, go to the other one.
Go to the third one.
Good. Well, you're up to 5 and
That's you.
7. 57. 5 and 7. ZL3RC VK7 Mike Oscar.
Now, bear in mind, he's copying me.
Yeah.
That's right. We're using 10 gigs for liaison across the Tasman. Thanks for the 5 and 6 to 7. And probably 5 and 6 to 7 would be more realistic at this end as well.
Probably.
Okay.
Anyone give that 5 and 6 to 7?
See what happens. Go to 432 and see what happens.
You give it 5 and 8?
3RC VK7 Mike Oscar.
Well, here we go.
Just repeat that, please.
That's well and truly.
Oh, sorry. No, this is my end.
Yeah.
Oh, Roger.
This must be one of Grant's ones. Yeah.
Okay, so is it this one?
ZL3.
No, this is your end. This is your end as well.
ZL3RC,
They're the only three that are there, Rex.
Oh, okay. Well,
Rogers was using a ACF T991.
Yeah.
Now, I've got the two of them. I've got the two of them, which I was going to play at the end. So.
Oh right, the two from Roger.
Yeah.
Okay. Well, let's leave it till then. Okay.
So.
Yes, I got a bit confused because I didn't think it was quite as strong as that.
So let's go back to. Sorry.
There. Okay.
There we are.
All right. Now, next slide. We can use the Radiosonde data to calculate the absorption on the path. I did this obviously after the event, and because there's no Radiosonde data in the middle of the Tasman Sea. All I can do is use the New Zealand data at some unpronounceable name.
Parauma. Sounds pretty good. Parauma.
And the Newcastle data and average
Okay.
them on the assumption that now there's actually very little difference at 432 between the New Zealand data and the Newcastle data. You can see it's on a 2,000 kilometre path varying between 4.5, 4.3 over the few days to 4.7. But the interesting thing is there is absorption even at 432 on a path of this length. And now I qualify this slightly because the ITU formula is only guaranteed from 1 gig to 54 gigs. But at 432 there was an ITU graph for the surface which suggested that it wouldn't be far out.
Okay.
So I think the 432 data is within a dB. Once you go up to 10 gigs you can see it really matters whether you're at the bottom of the duct or the top of the duct. And now that's an interesting question. You can see on the 1st of January at Newcastle was 36 dB at that end at the bottom of the duct. But at the NZ end it was only 36, so that averaged out at 31 dB. And so I've got figures there for the average at the bottom of the duct varying from 26 dB to 31 dB of absorption. Now the question is, where in the duct does the signal go? And when you get to the top of the duct, all the moisture decays over the duct.
Okay.
So you've got fairly high humidity at the bottom of the duct, and
By the time you get to the
the
top.
very low humidity.
Okay.
Now, the way I had a chat to Andrew 3OE or 3KAQ, and he said he thinks it's near the bottom of the duct where the signal travels, and that sort of makes sense when you think that you only need a very narrow duct for 10 gigs to propagate.
Yep.
So it's likely that it all happens at the bottom as soon as it starts to duct. Now, while you need a wider duct at 432, and therefore it probably needs to use most of the duct, it doesn't make much difference at 432 whether you use the top or the bottom of the duct. So I use the bottom of the duct for both.
Okay.
Next slide. Now this is what I call a system performance graph. Now nobody will be able to read this.
The figures at the end are important.
Yes, the figures, but I'll try and just run through what is important.
Okay.
The first thing is frequency, and what frequency does is it effectively means that everything you do in normal antenna gain is referenced to an isotropic antenna.
Yep.
And so your capture area is much smaller at a very high frequency.
Yep.
And so the normal propagation equations actually have what they call a propagation loss that's proportional to the square of frequency. Now, it's actually because the antennas are defined with respect to an isotropic antenna.
Yeah.
And I actually think that's not a good way of defining the gain of antennas, but nevertheless that's what's historically been done. So they effectively overcome this by putting a propagation loss factor in. Now if you go from can I read it? If you go from 432 to 10 gigs, that propagation loss factor is 27.8 dB or 0.6 dB. So if you've got the same size antenna, same gain antennas, you're already down 27 dB.
Yep.
The good thing is you can have much more gain at 10 gigs. And in this case, I think we had about 14 dBi at 432 and 35 dB or 37 dBi at 10 gigs. So that, and that's at both ends.
Yep. Okay.
So you're picking up about 20, you're losing 27, but you're picking up 25 at both ends.
Yep.
So you're ahead in terms of system performance. The downside is the absorption is about 20 dB higher, a bit more than that. And when you actually take account of absorption and system loss, it varied over those days between 10 gigs being 8.7 dB down, only 4 dB down on the middle day when it didn't work, and 13 dB down on the last day.
Yep.
Not a lot down, but certainly you would expect the signals not to be as strong on 10 gigs as 432, but primarily because of the absorption. Next slide. Now, one of the things you can use on QRA is what's called an added noise test. Who's done their added noise tests on weak signals? We have two good customers who know about added noise. So, three.
Three.
Now, when I applied the added, what I did was applied the added noise test to 432 and waited and increased the added noise until I was getting only about 50% decodes at RC equals 0. Because the messages changed all the time, you really need to use a common reference, which is RC equals 0. And at 10 gigs, I could apply 17 dB. So there's only 9 dB difference on that day, and we'd calculated it was only 8 dB worse.
Yeah, okay.
Or 8.7 dB worse. So it always
It worked.
it worked within a dB of what you'd expect.
Okay.
And what that tells you is the propagation loss in the duct. It's no extra loss because of the duct.
Yep.
And that's something that's a real unknown. In fact, Andrew KAQ has a formula for calculating the extra loss in the duct. Admittedly, he calls it an intuitive formula, which probably means it was more meant to approximate the results rather than
empirically give you what it's
Yeah.
showing. Yeah.
but I mean, he did good work. So,
But this is the evidence here is supporting that it's frequency independent.
that's right. So we now go to the next slide, and what I did here is I just transmitted single tones, and I thought this would be a better way of measuring the difference in signal to noise ratio and comparing them. Now the peak signal is down by about 10 dB, and in fact we had 13 dB of difference.
Yeah.
So the peak was within a few dB of what it should be, but the average was more like 20 dB down.
Yep.
So not quite right,
5
but
dB a second.
but bear in mind, we're dealing with numbers that are no more than 10 dB difference over such a range, and if the ducts were really varying in accordance with some parameter over a range from 432 to 10 gigs, you'd expect more than 10 dB difference, and 2 of the measurements were within a couple of dB. Now, there's a couple of reasons why this wouldn't be the same. For a start, I'm not measuring them at the same time because I have one system.
Yep.
And you can see, if you look at the 432, you can see just over time there's 10 dB of variation.
Yeah.
So depending on what time you picked it, it could be different.
Okay.
Next slide. So when you compare all those things to get a measure of duct losses, it was something between sort of 0.3 on the first test, that's the added noise test, 1.5 dB actually in 10 gigs favour on the peaks, and 6.5 dB below on average, so all pretty close in sort of what I would call. So
Okay.
next slide. I then looked at the spreading of the signal. Now this was a surprise to me because when I have seen ducts across to Western Australia, they've generally not been spread.
Unless you got windmills in front of you.
Yeah. Yeah.
Funny modulation pattern.
Yeah. Now there's a couple of possibilities. I noticed on the on the 10 across to Western Australia that there were occasions when I did see spreading, and then it would change into a nice stable signal. And I sort of put that down to the possibility you might have a troposcatter extension, because troposcatter certainly produces spreading because the signal's coming multipath over all these little scattering things. The other reason is these signals are much stronger than I had to Western Australia, and any spreading shows up much
Clearer.
more.
Yeah.
So I don't have a strong answer, but what I can say is 10 gig signals that I was measuring in that earlier graph were certainly spread more than the 1 hertz that I used to measure them.
Yep.
So that sort of 6.5 dB down mightn't be quite as bad if all the energy had been in the 1 hertz that I was measuring.
Yeah. Okay.
Now you can see on 432, well, it doesn't seem that spread. It's actually not that stable. And the reason for that is that Rogers was using an FT991, not GPS locked.
Right.
Now on 10 gigs he was coming down to 144, so any drift on his 991 would be proportionally a third of what it is on 432. It's probably there on the 10 gigs thing, but doesn't show up because of the wide spreading. You might be able to pick a bit of drift,
Yeah, a little bit.
Yeah.
which is probably his 144 meg IF.
Okay.
And on 432, it's sort of bouncing around in odd ways, which again I think you can put down to the thing not being GPS locked.
Okay.
So the important lesson for this is, if you're going to get involved in really understanding what's going on, the whole system has to be GPS locked.
Yes. Okay.
Now, what Glenn did, got hold of a couple of my files, and instead of analysing them in Spectrum Lab, he processed them in a program, a Python program that he's written,
A bespoke program.
which basically steers a PLL to the frequency.
Okay.
And he can do a bit of filtering and stuff. Now when he did that, even on just a single 1 minute transmission, you can see there is a gradual drift. That's only 2 hertz because that scales plus or minus 4 hertz.
Okay.
Well, no, it's almost 4 hertz drift actually on
Yeah,
432.
because it goes from 0 almost up to 4.
Yes,
But a lot more spreading on 10 gigs.
but a lot more on spreading on 10 gigs. Now, whether I'm pretty sure that the 10 gig stuff is propagation effects, that there's multipath signals going down a duct. Some of them,
Bit of scattering and
well, some of them go more times.
Or take a longer path or whatever.
Slightly,
Yeah.
and that's going on. That was a bit of a surprise to me because of what I had felt from the Western Australian stuff.
Yeah.
And now I'm equivocal, but I'm pretty sure they were so strong that I'm pretty sure that the Western Australia stuff just looked narrow because it was so weak. Yeah.
Okay.
Now, this is a set of ducts at both Newcastle and Brisbane over the day before and then the 3 days that we actually had QSOs.
They're quite different.
And you'll see they're enormously different. Now, some of those ducts at Brisbane are up nearly 2,000 metres. Some of them at the first one there is down about 300 metres at Newcastle. Unfortunately, we didn't have Radiosonde Data at present tense.
Right. Okay.
But I guess the lesson from this is the height of ducts, even round one single high pressure system, varies a lot.
Yeah.
Oh, truly. So what was it at the New Zealand end?
I didn't graph it, but I think it's
Oh, it's so coming slide. Okay.
next coming slide.
All right.
So here are the unpronounceable New Zealand name. No. That one is closest to Roger. There's a bit of a problem because the wind round that high would possibly be going over the South Island where there are mountains, because that Radiosonde site is on the west coast of the North Island.
Yeah, okay.
And probably a bit shielded.
Yep.
But basically we've got 4 Radiosonde sites roughly around the same high pressure system, and over the 3 days the first number is the intensity, and bear in mind anything more negative than minus 157 is efficient for a duct, and you can see you're getting intensities all over the place up to 1,000.
Yeah, wow.
And heights of ducts anywhere between sort of 400 metres and 2,000, 2,100, all round the same system. And now this is different to what people have determined for the path across to Western Australia. Now this may be because the Western Australian path all derives from this hot air coming from the Central Australia,
Yep, okay.
and this is a more complicated situation. But I think this is useful new information and
When you say
understand.
it's a more complicated situation, I would have thought it was a much more stable situation, because it's developing over water. It's not developing over land.
No, but the high pressure itself develops over Australia and then moves out.
Moves. Okay.
It moves
okay.
out over to the Tasman.
No. All right. Okay.
Yeah.
Yeah.
Whereas the other one is sort of continuously going eating up over.
It then tends to come down and then move up into the Tasman, because doesn't it
Yeah,
actually get
yeah,
up towards Brisbane and further
that's,
north?
Yeah, that's right. Yes,
Okay.
yes. You often find those highs that start in the Bight finish up higher up.
And they get a little bit compressed as they go past Tasmania, and then they expand out again on the other side.
You mean that's looking at the Hepburn charts?
Looking at the Hepburn charts.
That's because the Hepburn charts somehow only see what's going on at lower levels.
Yeah,
and once they see the high mountains in Tasmania, they don't give you any
and
data.
actually, what you mentioned about the higher level ducts as well is that they won't necessarily show on Hepburn either.
That's right.
Because they're very high.
Yes, in fact, Glenn found one just a couple of days ago where the Giannini repeater in Canberra was getting into Tasmania and all the way up to Brisbane, and they were getting multiple stuff, and Hepburn didn't show a thing. And when I looked at it, it was a high level duct about 2,000 metres.
Because we had that a couple of years ago to Lee Rainbird at Wagga Wagga,
Okay.
and his view to the south is completely obstructed by mountains.
Okay.
But we were having contacts over that, and Rex looked, and it was a high duct around 1,500 metres.
Yeah.
Okay.
But not on Hepburn. Nothing on Hepburn.
Nothing on
At all.
Hepburn.
And it was in March.
Yeah.
We need a facility.
So, I mean, what it says is it's worth looking at the Radiosonde Data.
Well and truly.
All right. Next slide. Now, you won't see anything. Unfortunately,
I think that's the right thing to say, Rick.
but those who can just look over this computer. What I've done here is on the 30th of December, I took what Hepburn said that it would look like on the 27th of December, I took what Hepburn would tell me it would be like on the 30th, 31 and 1st of January.
Oh, I see.
I mean, then he's updated it.
And so this is effectively showing you the same day updated by a different model.
Yeah.
And you can sort of see, for instance, on the 27th, it didn't look all that interesting here, but by the 29th,
it was really getting intense.
it said it was really good. So
Cool.
I think it's fair to say that Hepburn's all based on forecasting models. It gets more accurate
The closer you get.
the closer you
Same
get.
as weather.
That's right. That's all based on the weather models. But it is worth noting that you've got to keep looking at the Hepburn charts Okay, now the next slide I've just put here. There is another set of charts available from F5LEN.
Okay.
And he essentially does the same thing that Hepburn does, but he uses a European model of the atmosphere,
Okay.
whereas Hepburn uses a Canadian model of the atmosphere. His colour scheme is a bit different, in as much as he uses sort of light blue for black.
Nothing. Yep.
But certainly the stronger stuff are sort of oranges and reds, and you can see his model is similar. I mean, if you look at that shape and this shape, there's
And you wouldn't expect it to be wildly
no,
No.
and it probably just depends under what conditions he defines the different levels of what intensity, what it looks like.
Well, this is stuff for Andrew Clickachuck.
He is fairly.
Oh no, he's
No.
a different part of the
No,
atmosphere.
okay.
Yeah, but I guess the saving grace for this is Mr. Hepburn started doing this after he retired, and from my memory he's been doing it for at least 20 years. It may not go forever, depending on when he retired, and there are other people who can do something similar. I must admit, if you're used to Hepburn charts, this looks funny, but at least there might be something.
He is fairly accurate, the other guy, because I've checked charts before and they've been very, very similar to what
Right.
Hepburn said.
Yeah.
Okay.
Yeah.
Okay.
Not exactly the same, but
Yeah. All right. Now, the next thing is there's a lot of stories about the higher a frequency, the closer you've got to get to the level of the duct. Now, in practice, if you've got what we might call a standard atmosphere, we've all heard of the 4/3 rule. Well, the 4/3 rule only applies to what's called a standard atmosphere in a temperate region,
Okay.
which doesn't ever happen, but well, might happen once. In practice, the 4/3 rule means a radio signal tends to bend around the Earth. Not enough to bend right round. The 4/3 rule.
it'll go into space eventually, but yeah.
Well, that's right. But the 4/3 rule is based on a refractive index of about -47.
Right.
Remember, now 57 is what you need to bend right round the Earth.
Yeah.
So it can only do a little bit.
Yeah.
But the real world is the refractive index is quite different to the 4/3. Well, the average sort of.
Yeah.
And so what I did is applied Snell's law in increments that I can get from the Radiosonde data to see how much the bending actually occurs.
Okay.
And so that graph at the bottom on the left hand side shows how much the signal has been bent in degrees. And by the time it hits that duct, it's just over 1 degree of bending.
Okay.
Now the table at the top is designed to show you how much bending you need to get into a duct at 0 angle.
Okay. Not much.
And obviously if you're right in the duct,
Yep.
You're good to go.
you're good to go.
Yeah.
But as you go further below the duct, you've got to beam up at a higher angle.
Yep.
Now you can overcome that by beaming further and further out,
Yep. Yeah.
and that reduces the angle.
Yep.
The trouble is, the further you beam out, Earth's curvature actually curves the duct around, so there is an optimum maximum angle
Okay.
for any height below the duct, which is these green.
Yep.
And so if you're 20 metres below the duct and you beam out 100 kilometres,
Is that 20 metres or 20 kilometres?
distance to duct entry. Yes, you're right.
20
Yeah.
k's.
Yeah, that's the height below the duct is at the top, So if you're 100 metres below the duct, you can beam 20 metres out, and you need half a degree of bending.
Yep.
And you can see if you go increasingly further out, there gets to a point where Earth's curvature kills you. But generally, the optimum is, something like about 1 degree that you can get to. Now, when you actually plot a real world curve like that one, you can see it actually did curve around to just over 1 degree by the time it hit the duct. And in fact, once it hits the duct, it actually curves a lot more because of the increased refraction. And so this might force you to actually enter the duct at the top to get it right. But once you're in it, you're probably going to go along at the bottom. But now, this is data that I'm still playing with. I don't know that I'm doing it all perfectly yet, but...
And this is Kevin's contact. This is the...
That's right. This is Kevin VK4UH's contact. We know it works because he
it's
had
real.
the contact.
That was on 3.4.
On 3.4. But I think there's a lot to get out of the Radiosonde data that helps us know whether you can actually get into the duct a certain distance below. And interestingly enough, the two things tend to compensate, because you can, if you enter the duct higher up, you get more bending. So I actually have a feeling that you can even work 1,000 metres below a duct and still get into it because of this.
But not above. Not above.
But if you go above, it just bends up.
So you can be pretty much at sea level then, and you still might be okay.
And we've seen this, haven't we? We've seen high level ducts, and we're not much above sea level, and we get into them.
No, and even so,
now that's contrary to some of the papers that people talk about. So there's some interesting stuff there that I'd love to have a real physicist rather than a high school one.
You don't know a Nobel Prize physicist, do you, by any chance?
I do, but I don't think I can get him working on this.
He's working on something else, unfortunately.
Yes. Okay, next slide. Now this is really interesting, I thought. When this very intense duct formed off the coast of New South Wales, Glenn had a look at the rain radar. And there was this massive band of what most people would think is a massive band of rain.
It's not smoke, is it?
No. My hypothesis is...
It's condensate in the bottom of the duct.
No. That you're hitting the duct and bouncing off the sea. And so you're getting actual sea scatter from all the waves out at sea, which make you think
You're in the duct.
that there's all this rain out there in the clear sky. Now, if you, there's nothing in this area because you're so close that you'd have to beam at a high angle and go through the duct. So this sort of implies that there's interesting things to watch on the rain radar when there's ducting around, and it probably isn't rain.
Well, we know there wasn't much rain around there at that time.
That's right.
That would have been on 10 gigs too, or around about.
No, about 3 or 4 gigs. They run. Now, Glenn's actually got interested in what I'm doing, and this is good because we feed off each other. And he's written a Python program that he's still working on, but I just thought I'd show you what it's doing at the moment. And it's drawn a graph of the refractive index with height for a whole month at Melbourne. And now you can see that he's got a scale there that goes out to minus 1500, and on one day it actually went off the scale.
And that's almost 2,000 metres.
And that's right.
Yeah.
Now the histogram to the right is sort of a plot that goes from duct intensity at the bottom and height. And so when you get
a bit of an average.
well, you get an image of where the ducts predominantly are. So most of the ducts are sort of below about 400 and are in the range sort of 500 to 1500. When you get yellow, that means a number of them were on top of each other. The light blue probably means 2 are on top of each other, and the dark blue just means 1.
Okay. So it's that 500 to 1500 sort of range.
Yes.
Okay.
So this is just what is being worked on.
Okay.
Okay, so the results. Single tones were detectable on 10 gigs whenever he tried, even though on the middle day they were wandering around.
Still detectable.
QAA was decodable whenever he tried on the first and third day because we weren't struggling with a drifting GPS DO. 10 gigs contacts were 3 and 1 both ways on the first day, and on the third day when we started, 5 and 3, crept up to 5 and 5 both ways and did peak at about 5 and 7. So next slide. Now some of the key findings. Roger did this as well because he was using my larger petal dish.
Yes.
Once he picked it up, there was in azimuth there was essentially no skewing or spreading of the signal beyond the direct path, great circle path.
Yep.
And I had a similar result.
Okay.
But in elevation, I could beam up and down 2 degrees
Not change.
and it not change much at
Wow.
all. And I put that down to the fact that you can enter the duct on a number of
Different
angles,
Okay.
and you can also get reflection from the sea and into the duct at negative angles.
That's like trying to throw a rock through a hole in a fence.
Depends on how small the rock is.
Yeah.
How big the hole is.
Now,
And if the fence is even there.
I didn't actually talk about this at the time, but if you can remember back to those graphs of signal to noise, there was much more QSB on 10 gigs than there was on 432, and it was far more rapid. So very rapid QSB of up to 20 dB on 10 gigs on a time scale of a few seconds, compared to minutes or more on 432, suggesting that QSB rates increase in proportion to frequency. 10 gigs showed significant spreading up to 15 Hz compared to 432, which appears to be proportional frequency once you sort of take the drift out. Based on the Radiosonde data at Newcastle, Brisbane, all those sites, ducts vary significantly around the same high pressure system, well at least this high pressure system, from about 400 metres to over 2,000 metres.
I think that's the more fascinating
And-
result.
And also, when you enter a duct at one end, is it going to come out at a different height at the other end?
Well,
And across,
to.
and across the path, it's going to be going. It's not just one height.
Yeah, there's a lot of interesting stuff if you had a way of
Measuring
putting
it.
radars on flight. Well,
Because you may find like a duct might be actually curved along and going up and
out
down.
of interest, the Americans put a lot of American Naval Research Laboratories put a lot of effort into this, flying aircraft through ducts between Hawaii and San Diego back in the 1970s, because they were interested in the fact that the ducts can produce dead spots where you can't see the enemy coming.
And being able to predict them and then fly them, you could go stealth.
and so forth. Now, the N6NB sent me a copy of this paper. It's declassified.
No, you had it here the other night.
So there is interesting data around. They actually flew a microwave refractometer
Right.
up and down, measuring the radio refractive index, presumably over a fairly short part in an aircraft or below an aircraft or something. So there's data around. Now the last point, which unfortunately runs off the screen, is basically that from these tests there's no additional loss due to frequency in the duct other than absorption. If you can correct for absorption and system performance, the results of this suggest fairly strongly that you'll get the same answer.
Okay.
So
So that's more supporting evidence for the frequency independent.
that's right.
Well and
Yeah.
truly.
And this is new data as far as you're concerned, or a new perspective on this
I've never
situation?
seen anybody else come to that conclusion.
Okay.
The ham literature comes to the conclusion that there must be much more loss at high frequency because they
dependency.
can't work.
Again, that's only based on the fact they haven't been able to do it.
Or it's
That's
based
right.
on just path loss, maybe, that increases with frequency, I suppose.
Well, path loss doesn't increase with frequency.
Oh no, with the not taking into account the overall system gain. Of
That's
it.
right.
Yeah.
Yes.
The other question I had, if you can go back to the MLSP chart,
Oh
the,
yes.
the
Means-
hectopascals chart.
Mean sea level pressure
Yeah.
chart. Yeah.
I did notice something that I wanted to ask about.
Where we go?
So see where see where your path is,
Yes.
and approaching it is, I assume, is a front.
Like whole-
Yes, that might be an influence on it.
Now
Yeah.
I was going to say, did the because you've spoken before about prefrontal ducts,
That's right.
and whether that had any influence on it at all, because it's pretty close there and
It's
across
pretty
the
close.
entire path as well.
Yeah.
Correct.
Yeah. Well, certainly that was the day when we had the best signals.
Yeah.
I haven't looked back.
So whether it enhanced it maybe, or
Yeah, why the signals were better. Yeah.
Okay.
Are there simultaneous multiple ducts in fronts like this?
Occasionally. I've actually looked at all the ducts for the last 10 years between Hawaii and San Diego for the months of June, July and August, and I would say about 10% of the time there are when there are ducts, there are multiple ducts.
Multiple ones.
And that's obviously probably going to mean that the bottom duct is the controlling one because you don't go through it.
in Hawaii, that part's an interesting one because you have to be quite high at the Hawaiian end to get into the duct.
I
think
am
from
not
reading.
sure.
From reading, that's what I've seen.
Even from reading,
Really?
the people who've done the 10 gig stuff have all done it at high. Well, they've never done it on 10 gigs. That's the reason I'm interested in
The
going.
2.4, 3.4.
The 2.4, 3.4. They've also they did it way back in 1991 on 5.7, but they all did it from high levels.
Mm.
So you're
However,
thinking lower level.
they do consistently from down in the town work that path on VHF.
Mm.
So
And your findings with
Which
the
backs
fact
up
that you
the
can be low,
lower
but
and
still
beam up into it.
a couple of thousand metres maybe below the duct.
well, I don't know that
Okay.
I'm prepared to go that far below, but
Yeah,
there's still some interesting things.
probably not at sea level, but
But I'm not sure that you couldn't do it from sea level if you had the same system performance. And
but if you're too high, then
too
obviously
high you
too
won't
high,
get
yeah,
it.
problem.
In fact, the guy who did all the work at Hilo, KH6, something like EME, but it's not EME.
LME, I think.
Yeah,
something like that. Yeah.
EHE or something. He he says that as soon as you can see the sky, the sun shining through, the signal disappears. Now what that means is if the duct comes below you, where all the humidity is at the bottom of the duct, you can see the sun. And as soon as the sun shines on you, the duct's below you, the signal disappears.
Which reinforces you so that you can't be above it.
You can't
Correct,
be above it.
So you're better off to start low and go high if you need to.
Yeah.
Possibly.
I mean, my inclination is to start at the same height that N6NB did his records, because I know they worked, and the median height of the duct is above them.
What's the height of the Californian end? Do they usually
Lower.
They're usually not 400 or 500 metres or something?
Even lower.
Even lower.
600 feet. They talk in feet over there. 600 feet, 800 feet. They have.
They're right on the coast then.
They
pretty
have.
much low.
They have done a 920 meg contact from quite high up at the California end. And one possible explanation for that is that the duct actually finished well short of them, and because they were high up, they could get into it at a low angle.
This is this stuff.
Yeah. You can almost, there's so many variables that you can almost find a solution to every situation. But I think this sort of stuff is worth putting more effort into.
So have you deduced even an indication of what an average optimal, whatever that means, height is?
Depends on the location.
Yeah.
And
I mean, if you
what
don't know, I mean...
Well, what you do is you study the Radiosonde data for that site, and you find the heights of the ducts.
The average.
And, I guess it's best to pick a height that 80% of the ducts are going to be above you.
Yeah.
Yep.
Yeah.
Do they have a lot of good Radiosonde data along the Hawaii California part?
Not along it.
Not along it, but
at each end. Absolutely brilliant. In fact,
good.
they do it twice a day. So it's possible to get the data and change your height. If you've got locations selected in advance.
So really what you're saying is the Radiosonde data is pretty imperative to looking at that long term, so that you can plan roughly how high you're going to need to be to make sure that you're certainly not over the top of it.
Well, and then you'd update that when you got the latest Radiosonde data to decide.
If you had an average, if you studied it for a while, you'd get to put like a particular point, whether it's Newcastle or whatever, that it's going to be within this sort of range.
Well, that's what
and very rarely up here or down there. So you sort of start looking on Google Earth for a spot.
Yeah,
that's what Glenn's doing with the Melbourne one. Just getting a bit of an idea and an average, which probably varies a lot over the time.
He hasn't done it yet, but he's done some preliminary work where he actually does a correlation between the intensity of ducts at both ends to see whether in fact there is a duct.
They're the same duct.
Well, it doesn't mean that they're all the way, but if you know that you've got the right duct at both ends, there's a fair chance.
You showed the rain data he was looking at?
Yes.
There was no rain.
No.
So what does the weather department do when the weather radar says there's rain, but obviously there isn't any?
They just leave it and don't care about it.
But they have to be. The whole system is suspect then.
Well, we've picked up smoke on the radar here when it's been that thick. It's covered all of southern Tasmania.
But I think we've all been.
I suspect the people who are actually analysing the radar data do understand some of this stuff.
Yeah. That's the reason I asked the question. Because because they have an enormous amount of observational data, whether they're utilizing it or whether they're looking at it from your perspective is a different story.
If from their models they'd know there's no chance of rain, and this is obviously anomalous.
Yeah.
And they probably, you'd find there's papers that different meteorologists have written which people refer to when they get these odd effects.
Yep.
Probably even a manual that says, if you see this, look to page 22 or something.
Or maybe go outside and check.
There's another interesting thing too that you said about the angle of getting into ducts and things is the theory that with sporadic E paths that seem to go a little bit longer than what the normal hop distance would be, and at one or the at either end there's a bit of ducting shown on Hepburn, whether that's
yes,
it's hit the ocean and it's gone up and into the duct. Obviously not the other way.
I think there's quite often sporadic E and ducting combined.
Or conversely, actually, if it does hit the top of the duct and then comes back up and then hits the E layer again and then comes back down. I suppose that's possible.
Well, you've got to get up there first. But
yeah. But
if you got two E layers, you'd probably bounce off the ground or the sea.
It's not being able to get to the sea or the ground if the duct's below the...
But so you don't need the duct to be there to cause it. But, I mean, we did have plenty of examples, not plenty, some examples of extensions of meteor scatter by ducting beyond the range which meteor scatter from ZL to VK5.
Well, that was the example that I was thinking about with what was it when last week when we worked ZL, VK5 was working into but ZL, that's like 3,000 kilometres or just over what one hop should be.
Yes,
on 2 metres.
Well, the test of all that is, can you get through on 432?
Well, they couldn't. No. but at the ZL end, there was a small duct at the ZL end, just off the coast.
Yeah.
So,
and that's a reason why 2 metres is not a good frequency to use as an indicator of ducting.
Yeah.
Because you get confused by sporadic E. Because
but 432 you don't, because it doesn't get that high.
No.
Well, very, very, very
so rare that it doesn't matter.
That's right. Or it happens for such a short period of time.
Yeah.
That was fantastic, Rex.
Thank you.
Thank you very much for sharing, and also congratulations, given that it's actually the first ZL-VK contact on 10 gigs.
Yeah, indeed.
Thank you.
And I think that indicates that there's a whole lot more work and data to come in on this.
I think there's some really interesting stuff. Yeah,
it's just phenomenal, and it's dispelling potentially some of the long-held beliefs.
Yeah,
potentially.
Yeah.
So might be a worthy Gibbs Tech talk.
Definitely.
Except I won't be here.
Except he won't be here. He'll be in Hawaii.
You'll have to phone in or something.
Yeah, we'll get your Facebook message.
That sounds pretty doubtful.
We might have a stop press at Gibbs Tech to say it's happened.
You might. That's right.
And we might even, Peter would probably get you on the line if that was the case.
Yeah.
So yes, so fantastic, very good.
The time difference wouldn't be that close.
Correct.
Well, the other thing is, I have a basic principle: is you focus on one thing at a time.
Yes, and that's proven to be a successful formula in the past.
So far,
so
that seems to work.
Correct. So yeah, that's a good bit of advice for the weekend, and that's a great segue into the fact that this weekend is the summer VHF UHF field day.
Yay! So Richard, you better swap chairs.
That's all right. We can do because I do realise that it's actually 10 to 9.
Yeah. I went a bit over time.
This has been there was no time specified, so that's all right. But the summer VHF UHF field day, you want to do a bit of a
So we're hoping that everybody. Jeez, you'll get the ugly bloke on TV. Jeez. Yeah, so to read from the script, it's on Saturday and Sunday, and we're hoping that lots of VK7s are going to come out and dust off all the VHF, UHF gear. Hayden and myself are going to be set up on the mountain. We're hoping for good weather and we're hoping for lots of ducts. Woohoo! Never know. But look, we're going to give it a bit of a crack, and we'd like to see everybody just have a bit of a take a bit of time out to just come out and talk to us. Give us some contacts every 2 hours between, particularly for us, from noon to 8 o'clock.
Yep.
That's sort of
and
our 8 hour period.
150 on every band?
Pretty much 150 on every band, but look, this particular field day we're going to have a big emphasis on working people on FM, where before we were probably a little bit remiss and all excited about working on sets and on 10 gigs and all sorts of stuff. Yes. So this contest we want to spend a lot of time listening on channel 50 and 439 and 52525 for people that have got FM 6 metre rigs in their shack.
Well, handhelds.
Handhelds.
We're going to be running as a multi-op, so while one of us is manning the FM portion, the other one can be doing high band.
I guess 1296 can be 150 FM.
Certainly can. In fact, we're going to stick with 150, even though there's the possibility that maybe if we're working the guys up north, we might work them on SSB. That might end up being on 150.
Yeah.
But even though it might be a bit of a pain briefly for the guys that are listening on FM, it'll at least let them know that there's activity.
Yeah.
So the idea is to just try and work as many people with as minimal equipment.
And we do have about 3 or 4 or 5 VK3s that are keen to turn around and try.
On what bands?
All bands.
All bands. So
up to.
They're up to 20. Well, they're up to 24 gigs, but even higher.
But I think realistically, if we go, we've got 50 watts on 2.4, 30 watts on 3.4.
Yep. And
10 watts on 1296. It's a bit sad, but hopefully next time it'll be a bit more. But look, I think if we can just get some people with a bit of luck, there might be some ducting on 6.
On 2 metres and 70 centimetres, we should be all right with troposcatter to VK3, because they'll be up quite high and have quite a bit of gain beaming this way. So we should be able to make them out.
Some of the mainland guys are having a wicked effort. Like the VK4s have got a huge big setup on top of a big mountain with half a dozen operators.
Are they hiring the same house that Kevin did?
Yeah, I think so.
But
they've got 4 operators this time rather than the 3.
Right.
And VK3 KQ.
Yeah, they've got a huge outfit.
If you look on Google Maps where he actually sets up, it actually says field day spot on Google Maps. And you click on it, and there's even Google reviews for it with photos. That's how much they love that spot. That's just north of Ballarat or south of Ballarat.
So
Okay.
But they're really keen.
Okay.
So hopefully, look, again, our main aim is to try and encourage as many people in Hobart. We've got, I think Murray's going to be set up on Dorans Road.
Yep.
I think you're going to be heading
down
Ben.
Eagle Hawk
way. So
Ben's going to be roving.
Ben was talking about roving.
Woohoo!
Ben's definitely
On your
roving.
Ben.
Ben's roving. Yep.
On your Ben.
He'll be going all over the place, won't you, Ben?
On your Ben.
Love
it.
So yeah,
Cool.
I think it should be good,
Fantastic.
and hopefully the logging will all work out for the best.
Of course it will. Of course it will.
We have every faith.
Okay. Final thing before we go, I've got a bit of a stop press about the keynote speaker for the conference, WIA conference. It is Professor Elizabeth Leanne from UTAS/IMAS. She's actually a professor of English.
Okay.
However, she's done a whole lot of research, ARC sponsored research, into early expeditioners and all sorts of things. So I spoke to her today. She is really excited and really excited to speak to those people who are into radio, but also into Antarctica in some way, shape, or form.
Oh, wonderful layout.
So I said, well, you have plenty of people to speak to. So just very quickly, we've got a whole bunch of videos tonight. We'll start off with the 2 videos from Roger, which is the VK ZL 3 centimetre Contacts, both of his videos. So that's day 1 and day 3, I assume.
Yes.
We've then got the VK7HH Ham Radio Deluxe MFJ 1026 noise canceller video. which is just
which
recently
is yours,
recently been released by our studio audience members
and filmed by our studio audience host. Studio host.
Also, bit of a video I came across, which is just an introduction to 10 gigs and the X band for amateur radio, which I thought was actually quite a good one. Bouncing Signals Off the Moon, which is also a Ham Radio DX production.
That one again.
Also features people
and also promotes Bunnings too.
I really think it should actually need the Benny Hill music though.
It did originally. It actually did originally.
Oh, okay.
And I had to remove it because of a certain reason.
Yes. Okay.
So
right. I understand.
If you listen closely, it's still there.
Right. Okay. Moon Noise by VK7, VK5, honorary VK7, VK5KK, David.
I don't know if you like that or not.
And also a couple of his videos on the 122 gig project.
Okay, wow.
Which he's actually put out. So that's our videos for tonight. We won't get through all of those by the fact that it's just about to turn over 9 o'clock. So anyway, that's our show tonight. Thank you very much, Rex, and our studio audience of Richard, Hayden, and Larry. Thank you very much, and we'll get underway with our videos 73, and we'll catch you next time. Okay.